Hello YouTubers. In this video I will talk about powerful tool, PLC Sim. Please do not forget to like the video and subscribe to the channel. PLC Sim is a Siemens PLC simulator. It is powerful tool that comes in handy when you need to simulate some tasks without using a real PLC. Simulator is like virtual controller, of course with some limitations. Let's get started. To start a simulator you can use couple of ways. You can click online from menu bar, select simulation, and click start. Or you can use a keyboard combination, which is Ctrl, Shift, and X. Or you can click Start Simulation icon on the ribbon. I have a simple program that I would like to simulate before loading to the real PLC. My setup looks like that. I have a belt conveyor that is powered with electric motor. I have two photoelectric sensors. One is at the beginning of the conveyor for width and beginning of the box detection. Another one is at the end to detect runaways and stop the conveyor. I have three hitters that hits the box depending on its width. There is an inductive sensor that works as encoder. Belt conveyor transports the box. When the box triggers photoelectric sensor PS1, calculation of its width starts. Depending on the width of the box it will be hit by ejector 1, 2 or 3. If for some reason box will not be affected by any of 3 ejectors, it will trigger end sensor and conveyor will be stopped. First let's start the simulator. A pop-up window with a message that simulation disables all other online interfaces will show up. Click OK. Compact version of the simulator starts. As a real PLC it has 3 position switch separated into the 3 buttons, Run, Stop, and MRES. These 3 buttons work same way as 3 position switch on the real CPU. You can start CPU, stop it, or reset. Simulator acts same way as real CPU. You need to upload hardware configuration and your program into it. As you can see, loading preview is the same as for real PLC. After load is complete you can start the modules or take no action. Let's take no action and click finish. Project is loaded to the CPU. Now I am able to start it, or stop it by the click of the corresponding button. When I click start, CPU goes to startup mode and then run. If I click on stop, CPU goes to stop mode. From this point you can already monitor your project. To monitor the project you need to go online, just like with the real PLC. Click Go Online icon. As you can see I am in online mode. Click Monitor on Off icon to activate monitoring of your program. Monitoring works same way as with real PLC. I can start and stop the simulator from TIA portal, same way as with real PLC. there is a possibility to check the diagnostic messages of the simulator, just like of real CPU. There is no much of use of it, just to see that simulation works same way as real PLC. It helps you to discover online diagnostic functions. On the other hand, those messages will help you to determine some programming errors. Besides the compact view, you can switch to more advanced view, project view. To switch to the project view, you need to find an icon at the right upper corner of the simulator. By clicking that icon, you will switch to the project view. A project window has opened. To be able to operate with your program, you need to create a project. Create new project. New project with the setup of your PLC is created. Expand your PLC and open device configuration. The PLC with predefined inputs and outputs has been opened. Here you can already modify your inputs. I will try to modify some inputs. As you can see, by modifying inputs here, the state of tags changes in the user program. As in a difference to the compact mode, in project mode you can create simulation tables and sequences. Expand Sim Tables folder. There is already one simulation table is created. Let's open it. Here you can add your tags. You can add tags all at once, or one by one. By clicking icon Load Project Tags, all the tags of the project will be loaded into the table. To add tags one by one, you need to start writing tag's name and pick up the right one from drop-down list. Technique is the same as you add tags to watch table, tag table, and so on. Here you can modify tags and get a result according your program. I am about to create a simulation table that helps me to simulate my process. Simulation table is finished. Let's try to simulate the process. Button PB1 toggles between states of the motor. To start the motor, input PS2 needs to be high, as photoelectric sensor PS2, that is at the end of the conveyor, stops it if signal state is logical 0. Output K1 state is logical 1, it means that motor is running. State of input PS1 is logical 0, it means that there is a box in its sensing area. By triggering IS1, calculation of the width of the box starts, as calculation of the traveled distance starts as well. According to my simulation, this box should travel to the ejector number 2. I need to trigger input IS1 60 times to get the ejector number 2 to hit the box. Let's do it. Distance has been reached, ejector number 2 is active. I believe you have noticed that some lines are light grade, and some DAR grade. Only tags that are in lighter rows can be modified. And these tags are of type of the input. To be able to modify non-inputs tags, you need to click icon, enable disable modification of non-inputs tags. By clicking that icon, all rows of tags become light grade, it means that modification of them is enabled. I will change the set points for distances to the ejectors. Let's try to simulate the process again. Ejector reacted according new set point. It is challenging to click one input for multiple count. In this case, sequences come in handy. Beside the simulation tables, there is catalog with sequences. Sequences can help you to automate some tasks. Let's open sequence. Sequence contains beginning, steps and end. Here is the beginning of the sequence. Here is the end of the sequence. And lines between the beginning and the end are sequence steps. By adding the step, default interval for each step will be set. By default interval is 50, and units are milliseconds. You can change the default interval of the step here, or you can set different interval for each step. I will create a sequence that output HL will be activated in 2 seconds after the output K1 is activated. First of all, action needs to be changed from start immediately to trigger condition. My trigger is K1, and condition is logical 1. Change the default interval units into seconds, and interval to 2. Click the icon, add step. Select tag HL, and set its action parameter to logical 1. My sequence is done, let's try it. As you can see, execution time starts right after the K1 goes to high. After 2 seconds output HL became high, and after 2 more seconds sequence stopped, as it reached the end. By clicking icon repeat, sequence will be repeated until it will be paused or stopped. While sequence is in repetition mode, you will see the count of repetitions in brackets at the end of the execution time. If sequence is paused, it can be resumed at the last point. By clicking icon stop sequence, stops the sequence at all. Repeat sequence will help me to imitate the encoder. It will generate pulses on the frequency of 2 Hz. I am about to create a sequence, where state of input IS1 will be toggled by the frequency of 2 Hz, starting 2 seconds after the K1 goes high. That will imitate the encoder. As you can see, 2 seconds after K1 goes high, input IS1 starts to toggle on the frequency of 2 Hz. Let's try to simulate the process. The box was hit by ejector number 2. This time ejector number 1 has been activated. Let's change the frequency of the input IS1 to 1 Hz. Well, that was a small demonstration on what is the Siemens PLC Sim and how to use it. If this video was useful for you, please do not forget to like it and subscribe to the channel. Thank you for watching and happy coding.